All right, so welcome to the video key for topic 3, geometry. There's a lot of rhyming words there. So question number 1 says find the distance. I don't know why this keeps popping up, but anyway, find the distance. So we go to the formula booklet and 3.1, there is a distance formula. So it says take the difference in x's, square it, plus the difference in y's, square it, plus the difference in z's, square it. So here we do have each of these, an x and y and a z. So we're going to go ahead and just plug it into our formula. So we have parentheses 7 minus 2 squared plus, we're going to now go ahead and subtract the y's. So we have 3 minus negative 4 squared. You should put the negative 4 in parentheses plus, and now we have negative 1 minus 5 squared. Plug all of this into the calculator, literally exactly as is, and you can get the distance is equal to the square root of 110. Since we have to round in IB, not AB, to 3 significant figures, you go ahead and put this little equal squiggly equal sign, which just means as approximately 10.5. So our distance is 10.5 units. They don't tell us units. Find the midpoint. So the midpoint is right below the distance formula. It's right here. So we're just going to go ahead and apply that formula to it. So we have parentheses 1 plus negative 5 divided by 2, comma, 8 plus 2 divided by 2, and then we have comma, negative 3 plus 4 divided by 2. And again, these just become calculator. So negative 2, comma, 5, comma, 0.5. 0.5. Right? So this is our answer for the second one. Third one, find to 3 significant figures the volume and surface area of a sphere. Right? So volume and surface area of a sphere. So we have volume of a sphere right here and surface area of a sphere right here. So we just have to plug it in, but we're looking for the radius. So if you look in the question, if the diameter is 16, the radius is going to be half of that. So the radius is 8 centimeters. So first thing we want to do is go ahead and let's answer this in order. So volume is equal to 4/3 pi r cubed. So we're going to go ahead and plug numbers in. So 4/3, pi is just pi, r is 8 cubed. Plug this into the calculator and you're going to get to 3 significant figures, 2140 centimeters cubed. Okay, so that's your answer for the volume. For surface area, it's that other formula underneath, which is 4 pi r squared. If you get confused, right, it's 4 pi r squared right here. So then you're just going to go ahead and plug it in. So 4 times pi, our r is 8 again, and this is squared. Again, plug this into the calculator, and you get 804 centimeters squared is our surface area. And again, I'm rounding to 3 significant figures, okay? All right. All right, for the next question, it says find the volume and surface area of a cone. So volume is right here of a cone. Surface area, okay? So it says area of the curved surface of a cone. So that's just for the actual surface part of the cone. So if I have a cone that I can draw, right? Not bad. The actual curved surface is the formula pi r L, where L is the slant height, and then, which we'll find in a second, and then the formula for the top, that's a circle, right? The formula of a circle is pi r squared. So for the surface area, we have to add those together. So surface is equal to pi r L plus pi r squared, okay? Let's go ahead and find the volume because that is a little bit easier. So the formula is volume is equal to pi r squared h. So they tell us that the r, here we go, we have 1/3. So pi stays the same. They tell us that the r, or the radius, is equal to 6. So we take that and we square it, and then we multiply it by the height, which is 15. So we're going to take all of that, plug that into the calculator, round to 3 significant figures, and this is about 565 centimeters cubed. So that's the formula for, that's the actual volume. for the other one, for surface area, okay, so you have to figure out if they tell you that the radius is 6, so from here is 6 centimeters. And they're also telling you, man, these pop-ups, man. They're also telling you that this height right here is 15. So to find the slant height, which is our L, that's our L right there, you're going to use some Pythagorean theorem because this is a 90-degree angle. If you can't see this, let me just go ahead and make this in a different color. That's, there we go. This is right here is our right triangle. So 6, 15, and we need to find the hypotenuse. So the hypotenuse is going to be 6 squared, right? A squared plus b squared equals c squared. So 6 squared plus 15 squared is equal to the L squared. So L is going to equal the square root of 6 squared plus 15 squared. And if you were to find that, you can go ahead and break that down. So that's going to be, our L is going to equal 3 rad 29. And if you don't know that, it's fine. You could go ahead and just use the square root of 6 squared plus 15 squared. You could leave it like that. All right. So now we're just plugging this into our lovely formula here. So it's equal to pi stays the same. Our R here is 6. They gave it to us. Our L is either you could leave it as 3 rad 29 or the square root of 6 squared plus 15 squared. It's up to you. I'll use 3 rad 29 because that's what I found. I'm going to close those parentheses plus. Now we have to put this in. So this is pi. Our R again is 6 squared. And then you plug all of that into the calculator, and this is going to give you about 418 centimeters squared. Okay. Do not just take my word for it. Actually, please figure this out yourself. Next one, find to 3 significant figures, right? They tell us the volume and surface area of a square base pyramid with a base side of 5 and height of 9 centimeters. So we're looking for a square-based pyramid, okay? So this is volume equals, this is a right pyramid, so pi r squared h, okay, right here, that's 1/3, let's see. So this is of a square-based pyramid, okay? Square-based pyramid, yeah, so we have, right, according to this, it tells us the volume of a right, so volume is equal to 1/3, and then since it's a square, right, we're going to take each of the side, and it's telling us that that is 5, the base side is 5, so we're going to take each side and square it, and then we're going to multiply it by the height, okay? So we're going to take this formula over here and write that down. So volume is equal to 1/3 side squared h, and then we're going to go ahead and plug that in. So we have 1/3, our side again is 5, squared h, our height is 9. Plug all of that into the calculator and you get 75.0 centimeters to the third because it's volume, okay? Now we're also finding surface area, so again we have to find a slant height, the L, because we have a pyramid here. I'm going to do my best to draw a pyramid, okay? We have a pyramid that's a square base, so we also know that the whole thing is going to be 5. That means from the top down, let's see if I can draw that better, right? The top down is going to give us, right, that this is straight down. 5 cut in half is going to be 2.5. So our, right here, this is going to be 2.5. Whenever it'll feel like writing it, there we go. Okay, here we go. So this is a right triangle right there, and this is a base of 2.5, and they told us that the height is 9. So if I want to find this right here, which is our L, I'm going to do what we did above, right? So L is equal to the square root of 2.5 squared plus 9 squared. If you simplify that, you get the same thing as the square root of 349 divided by 2. And again, if you didn't know that, you could just go ahead and leave it like this. And then we're going to go ahead and plug that into our surface area formula, right? So we have the surface area of a pyramid. If I go over here again, the area of a curved surface, right? I have right here, the surface area that's of a sphere. So we're going to have to do this kind of by hand, but we have 4 triangles, right? We have 4 of these, 1, 2, 3 in the back and 4 on the left-hand side. So we have 4 times, and then the formula for area of a triangle is 1/2 base times height. So our base, the whole thing is going to be 5. So 1/2 times 5 times our height, which is the L that we just found right here, which is the square root of 349 over 2. So that's going to give us the surface area of the 4 faces that we have, okay? Now we have to take, once we have the 4 faces, we still have to find the area of the base, but we know that that's a square, right? The bottom is going to look like this, right? It says a base of 5, so 5 times 5 is going to give us 25. So that's going to be 5. Let's go ahead and write 5 times 5 or 25. And again, plug all of that into the calculator, and you're going to get that this is about 118 centimeters squared. Okay. Forgive my handwriting. It is what it is. All right. A grain silo is formed of a hemisphere on top of a cylinder. So you have a cylinder here and a hemisphere on top. All right, done, deal. So we want to find the volume. Okay, so let's go ahead and look for volume of a cylinder. Volume of a cylinder. Let's see if we can find that one. Okay, if I come to the top, volume of a cylinder is right here, pi r squared h. Okay, so if I go over here, so just for the volume of the cylinder, that's going to be pi r squared h. The volume of a hemisphere, right? So this is a sphere. Then hemisphere, hemi means half of a sphere. So the volume of I hate these extensions. The volume of the sphere, we had that formula right here, right? Volume of a sphere right here is 4/3 pi r cubed. So we're going to take this and write 4/3 pi r cubed, and then the volume of a hemisphere is half of that. Hemisphere is going to be half of that. So it's going to be 4/3 pi r cubed divided by 2. Okay. So to find the volume of the shape, we're going to take this right here plus this right here. Okay. So formula for volume of a cylinder, pi r squared. So let's plot pi. Our r is 5. It gives it to us. We're going to square that and multiply it by the height, which is 30. And we're going to take that amount and we're going to add it to this right here. So we're going to do 4/3 cut in half. That's the same thing as 2/3. And again, if you didn't know that, do that in the calculator. 4/3 divided by 2. You get 2/3 pi r cubed. So we just need to plug this in. 2/3 pi, our r is 5 cubed. Okay. So when you take both of these right here and plug it into the calculator, your final answer is going to be about 2620 meters to the 3rd power, because again, it's volume. All right, we're cooking with gas. Find the acute angle between the lines, right? So now we have 2 lines. So the first thing we want to do is we want to sketch it, right? So we have, here's our XY coordinate. So we're going to have 4x minus 3. I'll go ahead and do that in blue if it'll let me. That's blue, right? So 4x minus 3 is going to look something like that. It's going to be at -3, up 4 over 1, up 4 over 1, so on and so forth. And then we have another line, 5 minus 3x. So let's go ahead and switch a color here. Let's do that in green. Okay. So 5 is our intercept, our y-intercept. So I'm going to go to 5 somewhere around here, right? And then I'm going to do -3 slopes. So that's going to look something like this right here. All right. So now let's come up with a plan. All right, so it's very important to be clear on what is it that you're looking for. So we are looking for the acute angle between these two lines, right? This is an obtuse angle. This right here on top is our acute angle. So we're looking for that, which is theta, okay? And if you can't see this, if you plug this into your y1, plug this into your y2 and see where they intersect, it's going to be a little bit more obvious that this right here, this angle on top is what we're looking for, theta, and this is also theta because these are vertical angles, okay? All right, so how are we going to figure this out? So we kind of had a hint, right? We know that if we were to go like this and count this, right? Remember what we said? We're going to go 4 and over 1, right? That's our slope for this line right here. Maybe I should do this in blue just to be consistent. Blue, all right. So we know that this is 4 and this, our run is 1. Rise is 4, run is 1, okay? If I were to look at the green line, the second one right here, y2, and again, if I go green, right, we know that our, if we draw another line like this right here, we know that this is -3, and our run is still 1, right? So this is -3. So here I can see that there is a little right triangle here, right? There's another right triangle up here. So this is not an easy question, but let's go ahead and do this, right? So since I have my blue pen out, so tangent of, if I look and see what this angle right here is, I'm looking to see if I can find that. So to find that, I look at tangent because I'm looking for this angle right here. So tangent is equal to opposite over adjacent. So tangent of theta is equal to opposite over adjacent. Okay. So if I second tan that, or tan, inverse tan, I'm going to go ahead and get that theta is equal to 76 degrees. Your mode should be in degrees. So this right here is 76. Okay. I'm going to do the same thing with the green. So if I go over here to the bottom, let's see if we can figure out what this angle right here is. So I do it the same way, right? Opposite over adjacent. So tan of, I should call it different than theta, but tan of, let's call it angle B, is equal to opposite, right? Here's opposite, so that's -3 over 1. And since this is like distance, you don't really need the negative. We could just leave it as 3. And so that's going to be equal to, the B is going to equal about, it's going to be about 71.6 degrees. Okay, 71.6 degrees. So here, right here, I know that this is 71.6 degrees. And I want to look and see, how do I find this right here, this angle? Okay, so I know that this here on the bottom is about 71.6 degrees. Get rid of that right there. 71.6, right? And then this angle on top is 76 degrees, but you should be able to see a straight line right here, right? I don't know if you can see that, but let me go ahead and highlight this in orange. So this is a straight line right here, straight line. So I know that this is 71.6. Getting back, this right here is 76 degrees. So to figure out what the remaining angle is, I just do 180 whenever it feels like writing. 180 degrees minus 76 minus 71.6 degrees. And that gives me about 32.4 degrees is going to be the angle for the acute angle. All right, it's not an easy one. Number 8 is also not an easy one, but let's see if we can go ahead and figure this out. So we want to find the angle between line AG. So AG is from one end of this spectrum, right? all the way up to the other end. This is like in the front, forward, back, and this the G is behind, okay? So if you notice, the first couple of problems pretty straightforward. Now it's getting a little bit harder, okay? So from A to G. So for us to be able to figure out what that is, it's a pretty decent line. Okay, what I want to do is I want to go ahead and let's see if I could do this in a different color, if it'll allow me. Let's go with some brown, okay? If I were to go ahead and draw this, that was horrible. If I were to go ahead and draw this line right here, do you see that it makes a right triangle right there, right? So boom, this, right, makes a right triangle. So let's see if we can figure out triangle ABC. How about this right here? Boom. 1A, B, C. Okay. I want to find out whenever it'll stop doing this. I want to go ahead and see if I can figure out how long this is, how long this part right here is. Okay. So let's go ahead and I'm going to call that D. So to figure that out, I see a right triangle right here. So boom, right? Ace for triangle ABC, right? For AC, to figure out what the distance of AC is, I'm going to do the square root of, right? It's Pythagorean theorem. So 8 squared plus 4 squared, all right? So that's going to give us, right, if I add this, that's going to give us the square root of 80. So D is equal to the square root of 80. Now, how does that help me? That helps me because now if I take a look at, let's see if you could see it by doing a different color. Let's go with, can we do this purple? All right, purple rain. So now if you take a look at the triangle that we drew, which is triangle AGC, right? How does that help us? It helps us because now we know this distance, right? We know this distance right here. That right there is square root of 80. So now if we can go ahead and we also know, okay, we know one more thing. We know that this is 5, right? Which means that this is 5, means that this is 5. This is right here is also 5, okay? So in triangle, I'm going to be very specific, AGC, if I want to figure out what they're originally asking me, right, which is what is AG, right? What is this distance right here? Let's see if I can figure that out. I can use, we're looking for the angle, right? We're looking for angle AGC. So I'm looking really for this angle right here, the angle between. So to find angle AGC, let's see what we could use. We have opposite and we have adjacent. So which one has opposite and adjacent, right? Opposite and adjacent is tan theta is equal to opposite over adjacent. So our opposite side is going to be, so as I'm doing this, I'm realizing that we are actually not looking for that. We are looking, it says find the angle between line AG and the base plane. So here's AG and the base plane, which is this, right? The bottom part, A, B, C, D. So what I'm really looking for is this angle right here, which makes a lot more sense, right? That is an acute angle. So we have to find out what this angle is. So we're gonna look for, let's call it GAC, okay? GAC. So to find that angle right there, what we want to do is opposite over adjacent. So our opposite, right, is 5. So 5 goes on top. The adjacent side right here is radical 80. So 5 over radical 80. I plug that into the calculator to find out what the theta is. I do second tan. So tan -1 of 5 over radical 80. Hit enter in the calculator and it's going to give me about, this is about 29.2 degrees. Okay, about 29.2 degrees. All right. So the best way I can go through the next problem, question number 9 with you, is by using GeoGebra. So what we just figured out right now is AC, right? This line right here is equal to the square root of 80. That is equal to the square root of 80. That's like the base from AC, okay? They are telling us find the acute angle between these two diagonals, okay? So the acute angle, right? This is an obtuse angle. So we're actually looking for this angle right here. We're looking for this. Let's call this point M. So we're looking for this angle right here. Okay, that's the acute angle. Do we see this? All right. So let's see if we can figure out what AG is. Okay, so if I go back to this, I'm looking for AG, which is this right here, which is pretty easy to find out, right? Because we have a right triangle right here. So let's go ahead and start with that, okay? So in triangle AGC, okay? I always want to say where I'm starting. AG, AG or line segment AG is going to equal to the square root of square root of 80, that's our base, right? Squared plus, and again, all I'm doing is Pythagorean theorem, 5 squared, okay? So square root of 80 squared is 80 plus 5 squared is 25. So this is going to equal the square root of 105. Square root of 105 is AG, all right? So what we should notice is if we look over back at the diagram, just we want to always refer back to the diagram, AG, right? And EC are exactly the same. AG and EC are exactly the same because they're diagonals, right? So this goes from the front, right, bottom left to the top back, right? So AG and EC are exactly the same. So they are both equal to the square root of 105. So let's go ahead and write that. AG is equal to EC, which is equal to the square root of 105. And again, if you can't see this, definitely draw this in GeoGebra and you should be able to see that those two line segments are exactly the same. Okay? All right. Now, now we can do a little bit of something called law of cosines. All right? So let me show you where that's coming in. So we're looking for now, let's see if we can answer this, right? The law of cosines, the reason why we're using that is because now we know we have AG and EC, and we're looking to see triangle AMC. So triangle AM, right? M is the one that's in the midpoint, right? I call that M. Here is EC, right? So if I look, let me go ahead and put that point in a better spot. That's M. That's point M. So I'm looking to find, remember, I'm looking to find this acute angle right here. All right, so now how do I do that, right? So if I look at this, I have a couple of things. I have that the whole thing is equal to the square root of 105. So that means that this cuts it in half, right? This is equal to this, and this side is equal to this side right here. So the whole thing is equal to the square root of 105. So I could do the square root of 105 divided by 2 to figure out just what this part is right here. Okay. So now what I'm doing is I'm going to be looking at, let me see if I can highlight this better. All right. I'm going to be looking at, let's use pink. I'm going to be looking at this triangle that I have right here. All right. This triangle. And again, if this is easier for you on GeoGebra, then it's easier for you, but I will be allowed to draw on this. So this right here is equal to the square root of 105 divided by 2, and this is equal to the square root of 105 divided by 2, okay? So now how is that going to help me? That's going to help me because I can look and see if I can figure out what this angle is, right? If I can look and see what this angle right here is, to figure out this angle, which is what I ultimately want, all I have to do is subtract 180 minus this angle, okay? So I could do law of cosines here, and the reason why I say that is because Law of cosine says, if I use law of cosines, AM squared plus CM squared minus AC squared, right, divided by 2AM times CM. So I have each of these. That's why we're using law of cosines, because I want to try to figure out what this whole angle right here is, okay? So, yeah. Or you could find this angle, which we did, right? Didn't we find that this is 29.2, right? We found out that this angle right here is 29.2. So this is isosceles, so this is also 29.2 degrees, right? So to find out how much this angle right here is on the outside, I just have to take these two and add them together. 29.2 plus 29.2. When I add them, that's going to get approximately, right? This is going to be approximately 58.4 degrees. 58.4 degrees is going to be the answer for our acute angle. That's our acute angle between the two, right? 58.4. Now, let's just say, if I need to do it the longer way, right, I could do this for the law of cosines. So the square root of 105 divided by 2 squared plus the square root of 105 divided by 2 squared again minus the square root of 80 squared all over 2 times the square root of 105 divided by 2 times the square root of 105 divided by 2. And then once I get this answer, right, this is going to give me, for the angle, is going to give me that obtuse angle M, the obtuse angle M is going to equal about 121.6 degrees. And so if I do 180 minus 121.6, I also get about 58.4 degrees, okay? Either way you do it, you get it the same answer. But if you know and you figured out already that this angle, right, is 29.2, so if I go back to the GeoGebra, right, this angle right here is 29.2. This angle is also the same because this is an isosceles triangle, right, the one that I'm pointing to right now. So to find out this acute angle right here, I add the two interior, okay? And that's a geometry concept. And if you didn't know that, then you could do the law of cosines and do it the longer way. Woo, that was a doozy. All right, number 10. Find the angle theta in the following. Simple, okay? We have this angle right here. We are given opposite, our OPP, and we're given the hypotenuse. So to find out what the angle is, the sine of theta is equal to opposite, which is 1.8, over hypotenuse, which is 4.9. To figure out what the angle is, you second sine this, keep your mode in degrees, and theta is equal to 21.6 degrees. All right, done. Next ones are a lot easier. Number 11, find the length AC on the following triangle. So we're looking for this AC right here. So to figure that out, I would just use law of sines because I have, right, two sides, two angles. When I have two sides, two angles, and something's missing, I'm going to use law of sines. If I have three sides and one angle and something's missing, I'm going to use law of cosines, right? That's how you know the difference. So 3.8 law of sines, right, over sine of 80 is equal to AC, which we don't know, over sine of 55, right? Whatever's opposite. Okay, that's law of sines. And then you plug this into the calculator and you get AC is about 3.16 centimeters. 3.16 centimeters. If you have trouble figuring any of this out and how to plug it onto the calculator, please let me know. What did we just talk about, right? I have three sides, one angle, and something is missing. I'm looking for this angle right here. So cosine of C is equal to, and I'm going to use the second formula for law of cosines. Here we go. Here's our cosine rule. I'm going to use this formula right here. So cosine of C is equal to a squared plus b squared minus c squared over 2ab. And now it's just a matter of plugging in numbers. I hate this pop-up. Plugging in numbers right here. So I'm going to go cosine of c is equal to 12 squared plus 10 squared minus, and I have to do the one opposite, right? This one right here is going to be our c over 2 times 12 times 10. That's a 10. And then if I'm looking for angle C, second cos, and I get C is equal to 47.2 degrees. All right. Number 12, find the area of the triangle. This is a simple formula. So area of a triangle right here, right? 1/2 AB sine C. So let's do that. So I go area is equal to 1/2 AB sine of C. So I'm just going to plug in numbers. So 1/2 A, right? We have a 6 and a 15. The angle in between is the one that that's our C. So 6 times 15 sine of the angle in between them is 42. So it always has to be side, angle, side. You all have heard that before, and this is about 30.1 is our area. All right, 30.1, there's no units, so we're done. 14, the angle of elevation. So you have a tree of the top of a tree at a distance of 6.5. So this is 6.5 meters. And they're telling you that the angle of elevation, right? If a person's standing here and looking up, that is 68 degrees. They're looking at an angle at 68 degrees. So we're looking for the height of the tree. Okay, basic problem, right? So we need to figure out, is it sine, cosine, or tangent? So let's see what we're given. So this is the angle. We have an opposite and we have an adjacent. Therefore, we use tangent, right? Tangent has opposite and adjacent. So I'm going to go ahead and whenever my marker feels like writing, tan of the angle is 68 is equal to opposite, we don't know, over 6.5. Cross multiply here and I get x, or the height of the tree, is about 16.1. The height is about 16.1. All right. Cooking with gas, we're almost done. Question number 15. So x is about 16.1. Let's use meters. That's our thing. So a ship leaves port on a bearing of 30 degrees. That means that we're pointing north, and we have a bearing of 30. So I'm going to go ahead and draw this like this. So this is 30 degrees, right? This is pointing north. And it travels for 150 kilometers. So this distance is 150 km before docking. So there's some point over here that they are docking. Then it travels on a bearing of 110. Okay, so that means that it's going to go, this is, anytime it says bearing, you're going to point north. And they go 110 degrees and they go back, they go down, right? So this right here is 110 degrees and they travel for 80 kilometers. So this is for 80 kilometers. And then it says that they are docking again. So here at some point they stop and they dock. And we're looking to find the distance it must now travel to return back to where it started, right? So it's going to travel back to the point that it started, which is whenever this thing feels like, right? So it's traveling back to where it started, and we have to find that distance. All right, so a couple of things that were given, right? So if this angle right here is 30 degrees, then that also means that this angle here is 30 degrees because that's alternate interior angles. So that's 30 degrees. I'm also, I can figure out if this is a straight line right here. This is 110. That means that this is 70 degrees. Okay. So 70 degrees is right here. So that means that this whole angle right here is 100 degrees. Okay. All right, so if I call this the port, right, this is P, this is A, and this is B, let's just say. So this whole angle, angle PAB, is equal to 100 degrees. All right, so now let's see if we can figure out this distance right here. Okay, so I know that I can use, looks like I can use law of cosines, right? I have side angle side. I'm looking for this distance right here, D. So I have 150, right? That's one side. So 150 squared, I said squared, not degrees, 150 squared plus 80 squared minus 2AB. So 150 times 80 cosine, and the angle in between them is 100 degrees. 100 degrees, and then I go ahead and solve for this, and I get our D is equal to, should be about 182 if you did it correctly. 182, my bad. 182 kilometers, and that is our distance to get back to where you started from. All right. Question number 16, find the length of arc AB. So to do that, I go length of arc, right? The formula is right here. Boom, boom, right there, right? So L is equal to theta over 360 times 2 times pi times r. All right, so I'm going to go over here and just write that down. So S is equal to, right? So now I just need to plug in numbers. So our theta is equal to 55. So 55 over 360 times 2 times pi, and our radius is 6, not our diameter, okay? This whole thing goes into the calculator, hit enter, make sure your mode is in degrees, and you get about 5.76 centimeters is the length of this arc, okay? Arc AB. Question number 17 is area of a sector. Very similar to what we just did, different formulas. So area is equal to theta over 360. And this is area, so that's pi r squared is going to be our formula, pi r squared, and then you just substitute. So our theta is 110 over 360 times pi, our radius here is 10, so times 10 squared, and then you plug all of this into the calculator and you get the area of the sector is about 96.0 centimeters squared. All right, that's going to be our area. So that was question 17. Question 18. Find the length. So you have line segment AB and a midpoint 47. So the first thing we want to do is we want to get the y by itself. So if you were to take this and play around with it so that you get the y by itself, you're going to get y is equal to negative 2/3 x plus 5/3. And you should actually do this yourself and make sure that you are aware of that. And therefore the slope, or the m, right, is the number in front of the x, so that's negative 2/3. Since this says find the equation of the perpendicular bisector, the perpendicular bisector, the perpendicular slope is going to be the negative reciprocal of this. So if I take this and make it negative, it becomes positive, and I flipped this fraction. So 2 over 3 flipped is 3 over 2. So that's going to be our new m. So our m, and it has to pass through the point 47, and passes 47. All right, so I'm going to use my point slope form, which is y minus y1 is equal to m parentheses x minus x1. And this is also in the formula booklet, so please find that. Make sure that you're aware of where that is. Whenever these feel like closing, I can go ahead and show you where that is. So point slope. Yep, right here, right? So y minus y1 is equal to m times x minus x1. It's right here in this part. So now all I'm going to do is plug in some numbers, right? So I have this point. So y minus 7 is equal to, our m is 3/2, x minus our x1, which is 4. Okay. And now I have to take this and put this into the y equals mx plus b format. So you distribute here, right? Add the 7, and then this becomes, when you do that, whenever it'll feel like working. I know I've been saying that a lot, but it's okay. We're going to work with this computer. So this is going to equal y equals 3/2 x plus 1. Okay. So that is the equation of the perpendicular bisector of AB. Another one. So find the equation of the perpendicular bisector. So let's find the midpoint here. All right. So midpoint is just like we did question number 1. All right, we're going to take -3 plus 1 over 2, comma, -2 plus 8 over 2, right? And then just go ahead and figure out what that is. So that's going to equal -1 comma 3, -1 comma 3. Let's keep that in parentheses. So this is our x, this is our y of the midpoint. Next thing we're going to do is find the slope between those 2 points, okay? So the slope is our m. So to find our m, we go ahead and m is equal to y2 minus y1 over x2 minus x1. So let's go ahead and do that. So between these 2 points, right, we have 8 minus -2 over 1 minus -3. And if you were to go and plug that into the calculator, you're going to get 5 over 2. So 5/2 is our slope, okay? And then since it says negative, our perpendicular, we're going to take that and find the perpendicular, the negative reciprocal of that. So again, switch the sign. So it's going to become negative and flip the fraction. So that's -2 over 5. And so we're looking for a line that passes through -1, 3 and has a slope of -2 over 5. So we're going to do the same thing that we did in the problem above, right? Y minus y1 is equal to m parentheses x minus x1. So y minus our y1 is going to be 3 is equal to our m is -2 over 5 parentheses x minus our x1 is going to be -1. Right? And if you were to take this and it says find the equation of the perpendicular bisector, you're going to take this and this is the same thing as, to give it a second, I realized, okay, it's going to be the same thing as y equals -2 over 5x plus 13 over 5. And again, like I said, don't take my word for it, actually do it yourself. Question 20. So we're cooking with gas. So sites. Sites are, right? What is, come on, you got it. There you go. Sites are these little dots. So we have A, B, C, D, E. These are the labeled points. So those are our sites. A, B, C, D, and E. All right. Our vertices are going to be the points where the edges meet. So where did the edges meet? They meet at P, right? Q, R, T, and S. So P, Q, R, S, and T. All right. Finite edges. These are lines where you have vertices at both ends. So line PQ, right? That's a vertex. So PQ is one of the finite edges. And again, like I said, you have to just give this a second so it'll actually write. So PQ is one of them. And then we have R, well, QR is another one. I could just say it, but I'd like to actually write it out for you. QR is another one. Then we have RS. We have ST. We have PT. and we have QT. Okay, and again, these are lines where the vertices are at both ends. And then finite cells, by definition, what that is cells that are fully closed. Okay, so PTQ is one. So PTQ is a fully closed cell, and TQRS. So all that question was just some vocabulary. Okay. All right. So the next one, sketch on the above diagram, the Voronoi diagram for A, B, C, D, E. So all we have to do is do a sketch. They tell you what to do exactly here. But what we want to do is when we sketch, we want to take away parts that are unnecessary, right? Like we want to open the cell up. So let me just do this in a different color, okay? So this line right here needs to go away. This should have been erased. And we are going to go through a lesson with this if we have not already. So this one right here is erased, and this last one right here, this one we're going to erase. So we're just crossing out those 1, 2, 3, 4 lines. And then that is the diagram for A, B, C, D, E, right? We leave everything else. All right, so that's question number 21. Question 22. So it says, use the nearest neighbor interpolation to estimate the value of the function at 5, 4. So 5, 4 is going to be our little, right? It's going to be this point right here. And we're looking to see what is the site that is nearest 5, 4. What is the site that is nearest that? Okay. So to do that, what we want to do is we want to see which cell is closest to that. We can eye it and we can say, hey, these are far apart. So it's between these two and this one right here. You could do distance formula if you're not really sure, but you should be able to see that it lies kind of like this, like where it goes, right? So something like this. Trying to see where the actual lines are going to go. Something like this. It's going to go over a little bit, come down, kind of like this. And you should be able to see that this is going to be in cell A. But look again, if you're not really sure, find that distance using the distance formula, calculate that distance, and you'll see that 5, 4 lies in cell A. That's the one that it's closest. So what is cell A's value? That is 12, right? So the final answer is 12. All right. And again, like I said, you could use distance formula if not, you're not really sure about that. Last question, pumpkins, right? So towns are located at the points A, B, C, D, E. 1 unit on the graph represents 1 mile. The local authorities need to locate a toxic waste dump in this area within 5 miles of town D, but want it to be as far as possible from any of the locations or any of the other towns. So first thing we want to do is we want to find out, all right, looks like, yeah, looks like we should be able to use like somewhere around here. We should be able to go ahead and say, okay, where is it going to be a good place for the toxic waste dump? Within 5 miles of point D, so within 5, and want it to be as far as possible from any of the other towns. So basically we want to create a new site and we want to see what that is. So here we want to go ahead and figure out what is the slope of the line that we have right here. So let's see. So I drew 1 in purple, so we want to find the slope of this, and we also want to find the slope of this line right here. Okay, so for this one right here, you look and see 2 points. So we can look and see that this point right here, 6, 7 is a good point to use. and we want to figure out what is the equation of that line. And again, we did something similar where we're looking for the equation of a line. So 6, 7 is 1 point, and then we want to go ahead and see, okay, can we find on this line right here, the one in the purple, what is another point on the line? And we should be able to see that 6.5, 3, right? This point right here, 6.5 comma 3 is another point on that line. And basically what we want to do is we want to find the equation of this line, okay? So it helps by figuring out what is like another point. So it says, so we can take a look at this and see, okay, can we find the slope of this pretty easy? Yeah, right? It goes, let me use a different color because I used this like, all right, so it looks like it's going 1 down and over 2, right? 1, 2. So our slope, since it's a negative slope, is -1/2 for that one. And if I look for the purple graph right here, this is a positive slope. Okay, so m is equal to a positive. And how do we figure out what is the slope? The slope is, if I go from this point, right? If I go here, I'm looking to see what the slope is. So I'm definitely going up. See if I can find 2 good points. So if I have here 1, 2, 3, yeah, this works, right? 3 up, and it's over 4 to get to that point right there. So 3 over 4 is going to be our slope of that line. So I'm going to go ahead and plug this into the formula, right? So y minus y1 is equal to m parentheses x minus x1 minus x1. So we have our point, right? 6.53, and we have our slope. So y minus, our y1 is 6.5. No, our y, my bad, y1 is 3. So y minus 3 is equal to, our m is 3/4. So 3/4 parentheses x minus our x1, which is 6.5, right? I'm going to find the equation of this line. 6x minus 8y is equal to 15 is the equation of this line right here in blue. I mean in purple, right? So that's one line. Now, if I look at this line right here and I find out where they meet, then I'm done, okay? So here I'm going to go ahead and switch colors back. So I have y minus, our y1, right, is 7, is equal to our m, which is -1/2, times x minus our x1, which is 6. And if I were to take this and put this into a regular form, I have 2y plus x is equal to 20, right? So I have this equation, and I also have this other equation over here. So I'm looking to see where did those two meet, and again, I can do a point of intersection using our graphic calculator, and you should be able to see that our final answer for our question, this point right here where they meet, is going to be at 9.5 comma 5.25 or 5.25. That's where those two lines meet. All right, this is a lot. Stick with it.